What if I told you that the secret to finding alien life isn't hidden in the vastness of deep space, but inside a dust-covered hard drive at NASA from 10 years ago? Every single day, our telescopes screen data back to Earth, terabytes of it, yet 99% of these cosmic treasures are never even seen by human eyes. We aren't lacking better telescopes, we're lacking time. Welcome to the Data Graveyard, where the greatest discoveries in history are currently waiting for an AI to wake them up. To understand why we are so blind to these cosmic treasures, look at the staggering numbers being thrown in the faces of scientists every single day. We are currently living through a data tsunami. Think about the Vera C. Rubin Observatory. When it comes online, it's expected to generate about 20 terabytes of data every single night. To put that in perspective, that's equivalent to about 5,000 high-definition movies every single night. If a human astronomer spent their entire life without sleeping, without eating, just glancing at these images for 1 second each, they wouldn't even finish reviewing a single week's worth of data before they passed away from old age. This is the brutal reality of modern astronomy. We've become too good at looking, but we are terrible at seeing. We've built these magnificent eyes like Hubble, Kepler, and James Webb. They sit out there in the cold dark, blinking their shutters, capturing photons that have traveled for billions of years just to reach us. But once those photons are converted into ones and zeros and beamed back to Earth, they often vanish into what I call the knowledge graveyard. It's a paradox that trips up almost everyone. We assume that more data equals more discovery, but in the world of big data, the opposite is often true. Too much data equals zero data. When you have a billion haystacks, finding one needle isn't just difficult, it's mathematically impossible for a human brain. Our biological hardware, the wetware between our ears, is simply outdated for this task. The human eye is a masterpiece of evolution, but it was designed to spot a predator in the tall grass or a ripe fruit on a branch. It was never meant to scan millions of star charts to detect a 0.01% dip in brightness that signals a distant planet. We get tired, our attention drifts, we miss things. In fact, we miss most things. This has created a haunting phenomenon in the halls of NASA and the ESA, the ghost images. These are real files sitting on real servers containing the most revolutionary discoveries in human history. Maybe it's the chemical signature of chlorophyll on a planet in the Goldilocks zone. Maybe it's the strange, non-periodic pulsing of a star that shouldn't exist. These ghosts have already been caught, they are already found. But because no human has the time to open that specific file and look at that specific pixel, they remain effectively non-existent. We are literally surrounded by the answers to the universe's biggest questions, but we're locked out by the sheer volume of our own success. For decades, these archives have been growing like a digital jungle, burying artifacts of unimaginable value under layers of white noise and cosmic static. Scientists call this the bottleneck. We've spent billions of dollars on the capture phase, but we've neglected the comprehension phase. We're like a civilization that has hoarded millions of books, but has forgotten how to read. Until now. Because while a human would drown in this 20 terabyte nightly flood, there is a new kind of intelligence that thrives in it. An intelligence that doesn't need to sleep, doesn't get bored, and can see patterns in the noise that our eyes would dismiss as nothing more than a glitch. But how does it actually do it? How does a piece of code sift through a graveyard and bring a dead discovery back to life? To answer that, we have to look at the new digital archaeologists who are currently rewriting everything we thought we knew about the stars. But AI is not just a faster scanner, it is seeing things that the human eye, by biological design, simply cannot perceive. To understand this, we have to meet the new breed of explorers, the digital archaeologists. Enter exominer. This isn't a person in a lab coat, it's a highly sophisticated deep learning network developed by NASA. For years, the Kepler mission sat on a mountain of candidate signals, blips in the data that might be planets but were too faint or too noisy for human experts to confirm with 100% certainty. These signals were essentially in a scientific limbo.
Then, NASA turned ExoMiner loose on the archives. By learning from past confirmed discoveries and weeding out the false positives that trick human eyes, ExoMiner did something historic. It confirmed 301 new exoplanets in one single sweep. Think about that. 300 worlds that were already in our possession, already captured by our telescopes, but remained undiscovered because we didn't have the digital courage to claim them. These aren't just rocks. Many are gas giants and rocky worlds that redefine our understanding of the solar system's neighborhood. But finding planets is just the beginning. While we hunt for spheres of rock, other AI systems like Anomaly Match are hunting for the weird stuff. When astronomers ran this neural network through nearly 100 million image cutouts from the Hubble Legacy Archive, it did in 3 days what would have taken a human team decades. It flagged 1,400 anomalies, objects that didn't fit any known category. After review, over 800 of them were confirmed as brand new, never-before-recorded phenomena. We're talking about merging galaxies that look like cosmic collisions and ghostly rings of light that tell the story of the universe's violent past. However, the most mind-bending work is happening where there is nothing to see at all. Let's talk about the Gaia mission by the European Space Agency. Its goal is to map over 1.8 billion stars in our galaxy, but the raw data is just a chaotic swarm of dots. By using AI to analyze the stellar streams, the movement patterns of these stars, scientists are now able to see the invisible skeleton of the Milky Way galaxy. AI is acting like a cosmic time machine, tracing these movements back billions of years to reveal that our galaxy is actually a cannibal, having swallowed smaller galaxies in its youth. Without AI to process these trillions of orbital calculations, the 3D structure of our home galaxy would remain a flat, two-dimensional mystery. And then there is the ultimate invisible prize, dark matter. We know it's there because of gravity, but it doesn't emit light. It's the ultimate ghost. For years, scientists had to run full physics simulations that took millions of hours of supercomputer time just to guess where dark matter might be. Today, AI models like Cosmogan are changing the game. By using generative adversarial networks, the same tech used to create deepfakes, AI can generate maps of dark matter distributions that are statistically indistinguishable from reality. It's taking the faint warping of light from distant galaxies and reconstructing the invisible web that holds the entire universe together. It feels like magic, doesn't it? We're pulling high-definition reality out of what looks like static on an old television screen. We're discovering that the void of space isn't empty at all. It's crowded with information that we were simply too primitive to decode. But this raises a haunting question. If AI is the one doing the seeing, can we always trust what it shows us? As we hand over the keys of discovery to these black box algorithms, we are entering a strange new territory where the line between observation and simulation begins to blur. Because while AI is a master of finding patterns, it is also a master of creating them. And as we'll see in the next part, when AI begins to predict the future of our stars, or even the safety of our own planet, the stakes move from the theoretical to the survival of our civilization. But as we hand over the keys of discovery to these black box algorithms, we have to ask a dangerous question. Is AI truly discovering the universe, or is it just telling us what we want to hear? You see, AI is a master of pattern recognition, but it can also be a master of hallucination. In the world of science, this is known as the bias problem. If we train an AI to look for Earth-like planets, it might start seeing Earths in every smudge of digital noise. It's the ultimate deep fake of the cosmos. For instance, when models like Cosmogan reconstruct dark matter, they aren't taking a photograph, they are making a statistically probable guess.
This is why the human-AI symbiosis is so critical. AI is incredible at finding the average, the expected, and the masses, but human genius has always lived in the anomaly. The greatest breakthroughs in physics, from Einstein's relativity to Hawking's radiation, didn't come from following a pattern, they came from breaking one. If we rely solely on AI, we might find 10,000 more planets just like ours, but we might miss the one impossible object that rewrites the laws of gravity. AI finds the haystack, humans must still find the needle. However, while we debate the philosophy of truth in deep space, AI is already performing a much more grounded and urgent task. It is acting as a planetary shield.
Most people think of space discovery as a luxury, something for billionaires and dreamers, but it's actually a matter of survival. Every few minutes, our sun belches out massive clouds of charged particles. If a major solar storm hit Earth today, it could fry our satellite networks, knock out the global internet, and plunge entire continents into darkness for months. We're talking about a trillion-dollar disaster. For decades, we were flying blind, only able to predict these storms minutes before they hit. But now, as reported in journals like Nature, AI is changing the stakes. By analyzing centuries of solar activity in real-time fluctuations in the magnetic field, AI can now predict space weather with unprecedented accuracy. It gives us the one thing money can't buy: time. Time to put satellites into safe mode, time to protect our power grids, and time to prevent a digital apocalypse. And it doesn't stop with the sun. Let's talk about the city killers, asteroids. Programs like the Asteroid Institute's Thor algorithm are currently scanning those same data graveyards we talked about earlier. In 2024 alone, this algorithm identified over 27,000 new asteroids, including dozens of near-Earth objects that had been sitting in archived telescope images for years, completely unnoticed by humans. The data was already there. The threat was already there. We were just too busy to see it. This is the real value of AI in space. It's not just about finding a shiny new planet to name after a celebrity. It's about the fact that we have finally built an intelligence that can keep watch when we are tired, an intelligence that can sift through the Nye Zulio, the data graveyard, to find the one signal that saves our civilization. We are no longer just observers of the stars. We are the first generation of humans to have a digital guardian that never blinks. But as this guardian grows more powerful, the line between the tool and the master begins to thin. We are moving toward a future where human-made discoveries will be the exception, not the rule. So, where does that leave us? Are we still the explorers, or have we just become the curators of an AI-generated museum of the universe? As we wrap up this journey through the Nye Zulio, the answer might be more unsettling than you think. We've spent centuries believing that to see further, we simply needed bigger glass and taller mountains. But as we've seen today, the most profound frontier of the 21st century isn't a physical place in the sky. It's the digital archive right here on Earth. We are officially entering a new era of archaeology of the future. A time where our greatest scientific breakthroughs won't come from a new telescope launch, but from an AI brain finally learning how to read the history we've already written. The data graveyard is coming back to life, and it's revealing a universe that is far more crowded, far more violent, and far more connected than we ever dared to imagine. AI has shown us that we haven't been failing to find the answers, we've just been failing to recognize them in the flood of information. It serves as a humbling reminder: the truth isn't always out there. Sometimes it's already here, buried in a folder we haven't opened yet. But this is just the beginning of the symbiosis. As these algorithms become more intuitive, they won't just be our librarians, they will be our scouts, our guardians, and perhaps eventually the primary authors of our scientific papers.
It leaves us with a fascinating and slightly haunting thought. If an AI can find 1,000 planets in a weekend, what else is it going to find when we give it the keys to every archive we own? Now, I want to hear from you. If you could command a NASA super AI to hunt for just one thing in those secret data archives, one specific signal, or one hidden truth, what would it be? Aliens? A new law of physics? Or maybe the origin of time itself? Leave a comment below, because who knows, the answer might already be sitting on a hard drive, just waiting for the right line of code to find it. Thanks for watching, and I'll see you in the next analysis.